Hi everyone, my name is Chet, and unfortunately I can't make it to Locate 15, so I've put together a quick video to give you all an insight to my research. My research is titled Automatic and Intelligent Orchestration of Web Services Utilizing Semantic Web Technologies. Now, to the members in the audience unfamiliar with these terms, web services are simply services found on the web that offer functionality in terms of processing, and orchestration simply means the linking or chaining of these web services to produce useful output. What is the objective of my research? Well, as the title has already probably hinted, I'm researching ways to use semantic web technologies to help computers understand what a user's query means, and automate the usually manual and human process of linking web services together to achieve an objective. Certain research questions pop up. Where do we obtain this knowledge? Where do we get the data sources? Which web services do we invoke once we have this knowledge and data? What order do we run them in? And how can we present them in the best way to the user? The best way to introduce everyone to my research would be to jump right into an example. Here is a complex user query that a user has input into the system. Where do I evacuate to escape the flood in my area? Now, a computer cannot understand the semantics of a complex user query written in natural language. Unlike you and me, computers cannot truly understand what a query means. First, we break the query up into simpler pieces so that the system is able to understand the queries a bit better. This can be done via a natural language processor. The first query that the natural language processor extracts is, where do I evacuate to escape? This implies the determination of a safe location. The second bit that is extracted is simply the flood. At this point in time, a computer has no clue what a flood is. We'll get back to this later. Finally, the last bit that is extracted is in my area. This implies that the query is related to the user's current location. Back to the flood. How do we help the computer understand what a flood is? We can use an ontology to help the computer understand the meaning of a flood. But first, what is an ontology? An ontology is a framework for representing knowledge. It is a fundamental building block of the semantic web. Ontologies store information about things and how they relate to other things. By building a large graph of interrelated things, a computer can stimulate human semantic knowledge. A little more depth into ontologies. Ontologies are written in OWL, and in this specific project, the sublanguage of OWL being used is OWL-DL. This is to assist us in logical decision-making tasks. Back to the flood that the system currently has no idea about. Let's refer to a weather ontology, for example Sweet, and see what information we can find out about flooding and how the information stored within the ontology can help us. Here's a graphical representation of what is stored inside an ontology. Up the top, we have flooding. Within the ontology, we have other items that are related to flooding, and more items that are related to these items as well. Let's work our way through this ontology. Flooding is caused by rain, and rain can be predicted using rainfall prediction tools. At this point, we know we can use a rainfall prediction ontology to find out even more about rainfall predictions, or we can use a rainfall prediction web processing service. Again, a bit more depth into what a WPS is. It is a standard that specifies that all geospatial web processing services must specify their inputs, their outputs, and their function. This is a great help for orchestration because we can search for the WPSs we need, as well as what order they need to be run in. Unfortunately, the current metadata specified in the standard is not tailored for automatic orchestration, and it's actually a very big part of my research to improve on this metadata to allow for automatic orchestration. Back to the rain bit in our ontology. Rain affects water catchments. This signals us to look for nearby water catchments. Unfortunately, this isn't too useful to us, however it may be vital information in other queries. Back to flooding again. Flooding is a severe weather condition, and severe weather conditions can be identified by bomb warnings. This is another viable endpoint. We look for weather warnings in the area to identify if the user is in a potential flood zone. However, this isn't too useful for our initial query, which is how do we evacuate the flooded area? Once again, flooding can be predicted by flood modeling web services. And it so happens that the ontology has the location of one of these stored. OWL-DL is useful in that it can infer and deduce that this is the most relevant and efficient decision based on the nature of the query. Enough with the flooding ontology for now. Let's go to another part of our query, which was, where do I evacuate to escape? This is a common process. It is most likely there already exists an ontology or business process model that will list steps or guidelines for evacuation routines. In this case, we assume to calculate a safe area to evacuate to is simply done by moving the user to the closest civilian road not affected by the flood. Or, in geospatial computational terms, where the flooding polygon does not intersect with the road. Let's recap really quickly. So with the help of ontologies, we have a web service that will predict floods in a given area, and we know how to calculate a safe area to evacuate to. Here's a mock-up of a WPS ecosystem, where web services provide geospatial web processing services to the public or anyone that may need them. They may be located anywhere in the world, but are accessible by anyone on the web with a relevant URI. Here we have the flood modeling WPS, where the input is the user's current location. It outputs a polygon in projection X that represents nearby areas that are predicted to flood in the next, say, 24 hours. This is input into an intersection WPS that we will use to calculate if the user is in an area that will potentially be flooded. It takes in a polygon and a point on a map, which is the location of the user. We already have the user's location obtained via GPS buffering. However, for some reason it is in projection Y. Now you will recall that our flooding polygon is in projection X, and it will not be wise to do geospatial processing on datasets that have different projections. Now the system is intelligent enough to identify this and will attempt to remedy the situation. Here we have the user's location again in projection Y. It so happens that there are projection conversion WPSs out there that will do the conversion for us. Here we will see that it will output the user's location in the desired projection. Now we can do the calculation to see if the user is in a flood danger area. And yes, it turns out that the user is right in the middle of an area that will be flooded soon, as predicted by the flood modeling WPS. We then talk to a safe zone determination WPS that takes in the current position and potential hazard polygon and outputs the closest civilian road that isn't in the hazard zone. We now have a location of where the user should evacuate to. Unfortunately, just telling the user which road to go to isn't the most helpful of things. We therefore use ontologies, again, to help determine the best way to present our results to the user. So from ontologies, the system is intelligent enough to realize that routing the user to the safe location using the Maps application on his or her smartphone is the most beneficial way to present the results. The user can now see directions and routes to take to get to the safe location. Ideally, the user is hidden from the processing and data that goes on in the background. In a classic scenario, it will be a person or even a specialist manually searching for data and services and determining which order to run them in and process any data conversions. My research aims to automate all of that by helping computers understand the semantics in a user's question and utilizing semantic web concepts, such as ontologies, to answer the user's query. And that's it. I hope everyone has enjoyed this quick overview of my research. If any of you have any queries at all, please direct them to my supervisor so he may pass these on to me. Thank you everyone, and have a pleasant day.